Hey everybody. So this week we're going to take a break a little bit from dividing polynomials and factoring. We're going to get back to that next week. And this week we're going to do a quick little side tangent on reducing or simplifying radical expressions, that's square roots. And that's going to lead us into roots or x-intercepts that are technically there in polynomials, but sometimes don't show up on the x-intercept. We're going to get into something called imaginary numbers, and we'll do that next time. But before we do that, I want to do a quick little recap on simplifying radicals, because this will show up when we start discussing imaginary numbers next time, so I thought it would be a good idea to just do a quick little recap. So today, hopefully, will be a break from some of the harder problems we were doing the last couple weeks. So here we go. Simplifying radical expressions work like this. This rule we're going to use almost entirely to do these problems. This is just the product rule for simplifying radical expressions, and it works like this. A square root that can be multiplied, like two numbers to be multiplied together in a square root, can be separated into two individual square roots. What do I mean by this? That means that, for instance, the square root of 2 times 3 is the same thing as the square root of 2 separately times the square root of 3. If you don't believe me, you can take out a calculator and do that. So for instance, the square root of 2, I don't know if you guys can see that, times 3, oh, there it is going to be 2.449, right? The square root of 2 times the square root of 3 separately is also going to be 2.449. So this, again, is equivalent. Well, why does this matter? Well, when we start what's called simplifying, we can use this to our advantage to make square roots just a tad bit easier. Let me show you what I mean by that. Or not easier, but more simplified. If I look at the square root of 12, for instance, we're going to do a couple of these. How could I think of this problem multiplied out into smaller numbers? So the way you do this is you think of factors of 12. Well, the factors of 12, there are several of them. Let's see here, 1 and 12, 2 and 6, 4 and 3. And I'm going to break this down like this. Square root of 12 is the same thing as square root of 4 times 3. Hope you guys would agree. Now, because of that product property, I can split this like this, 4 times square root of 3. And what do you know about the square root of 4? Well, the square root of 4 is 2. So I could think of this really as 2 times the square root of 3. This is what is known as the simplified version of that radical. And you would stop there. Now, some of you might have been like, well, could I have broken it down like this? 6 times 2. And the answer is yes, you could break this down into 6 times 2. But the problem with this is square root of 6 and the square root of 2 are both not nice square rooted numbers, meaning like if you square root on a calculator, you're not going to get a whole number. Therefore, this would be the wrong route. So the trick to this really is breaking the 12 down and thinking of factors of this that are nice roots, or what are known as perfect squares. 4 is a perfect square. Pretty much any number you can square root is a perfect square. When I mean square root is like square root to a nice number. So for instance, let me give you a list of those. 1 squared is 1, so the square root of 1 is 1. 2 squared is 4, so the square root of 4 is 2. You guys will definitely recognize all of these different numbers. These are, again, these go on and on and on, but these are known as the perfect square numbers. So when you're breaking down a number, try to break it down into one of these numbers. This will make your life a lot easier. Let's talk about 45. Think of any of these numbers that might go into 45. And, well, 4 doesn't. But if you guessed 9, you're absolutely right. 9 times what is 45? And the answer is 5. So I can think of this as 9 times 5. Separate it using the product rule for radicals. Square root of 9 is 3. And square root of 3, or 3 times the square root of 5. And then you are done. Now, some of you guys are like, well, how do I know I'm done? Well, when you look at your square rooted number, you don't want to be able to break it down any more than you already have. So if you think of 5, the factors of 5 is 1 and 5, you can't really break down that square root anymore. Therefore, you are most certainly done. And that is why this is the simplified form. Let's talk about this last one. 400. Well, there is quite a lot of numbers that go into 400. But what I want to do is I want to think of the biggest nice square rootable number that goes into 400. Now, if I look at just these numbers that I listed so far, you might say 25, for instance. But if you go a little bit further, and the square root of 25, by the way, is 5, you might remember that the square root of 100 is 10. So maybe the best way to break down 400 would be 100 times 4. So let's go ahead and do that. The square root of 100 is 10. The square root of 4, by the way, is, well, 2. So this actually is just straight up 20. So 20 squared is 400. So that just ends up being just a perfectly nice number. So you can use these to simplify these. You can also use these to take bigger numbers, break them down into eventually nicer numbers that you might not have been able to do in your head, because who knows that the square root of 400 is 20. I don't remember that kind of thing. So this becomes nice. So enough with numbers. Let's talk about variables and exponents. So square root of x squared. Now, square root of x squared, it's probably a good idea to think about what again does a square root do, or what is it asking? If you remember, square roots just pretty much mean is what squared equals that number, okay? So I can ask the question, what times itself equals x squared? That's pretty much what a square root is asking. And if you think about it, what times itself equals x squared? Well, that's x, right? So x times x equals x squared. So the square root of x squared is just x, right? You can ask the same question for this. What squared equals x to the fourth is what the square root is asking. What times itself equals x to the fourth? Similarly, x squared times itself would get you x to the fourth. So this would just be x squared, right? And if you're kind of guessing the pattern, what times itself equals x to the 6, you've probably guessed x to the 3 times x to the 3 would be x to the 6. So the square root of x to the 6 would just be x to the 3. Now, what do you notice about each of these things? Is that when you square root a exponent, especially with a variable, that it looks like this number to this number, this number to number is like it's almost getting cut in half. This guy would have a 1 technically, right? 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3, right? So there's definitely a relationship there. So you can definitely even square root these numbers. But the question is what if I have an exponent that isn't nicely divisible by 2? Do you leave it as a decimal, for instance? Like if I had x to the power of 7, do I just leave it x to the power of 3.5? Because 7 divided by 2 is 3.5. And the answer is no. We do not in I guess radical or exponent world want decimals or fraction exponents. So there is a way you can do this, and we're going to talk about that simplifying right now. So x cubed, how do I actually write that simplified? So the way you do that is you break it down just like you would a number. You have to ask yourself, what times something gives me x cubed, but I want one of those factors to actually be square rootable. And the way I do this is I think of what is the next even number down from 3. And the even number that comes right before 3 would be 2, right? So x squared. X squared times what is x cubed? X, right? Now, this can be broken down using the product property of this like this, right? X squared times x, right? And what's the square root of x squared? Well, we already found that out. That's just x, right? Times the square root of x. So this would be the simplified version of that. Let me show you again with x to the 9th. Hopefully you get the hang of this. What's the even number that comes before 9? 8. Times an extra x would give you x to the 9th, right? Break that down. X to the 8th times square root of x. Well, what's the square root of x to the 8th? What times itself equals x to the 8th? And the answer is x to the 4th. And there we go. got a leftover x there, and that would be actually how you write it. Let's try x to the 21st. What's the even number that comes before 21? So there's 20 times the next additional x. X to the 20 times x to the 20, square root of that, that's going to be x to the 10. Again, that idea that you're just kind of having the exponent to figure out what it equals when you square root it, times the additional square root of x, and there you go. Okay, let's put it all together and try some bigger problems. So if we take a look at this problem, when you get into problems with both numbers and variables, it can be kind of daunting if you try to do this all in one go. So what I like to do is I like to separate this into kind of 3 separate problems right next to each other. And then eventually I put everything back together. So let's start with 75. How can I break down 75? What are factors of 75? Thinking specifically, one of those factors have to be square rootable. I'm thinking 25 times 3. So we do 25 times 3. The square root of 25 times the square root of 3. Square root of 25 is 5. There we go. So this part of the problem is simplified. Now let's talk about this part of the problem. And you can almost, like, if you want, think of these as kind of like their own problems, right? And then at the end we'll put them together. Like before, we could do x to the 4th times an additional x would give you x to the 5th. Square root of x to the 4th is x squared times the square root of x. So that part is done for this one. And then this one is just y to the 4th, so we can already square root it. It's a nice even number. So that's just going to end up being y squared. So we're going to take these 3 answers for those separate problems and we're going to merge them together. The way mathematicians like to do this is they like to take the things that don't have square roots, put those numbers first, or numbers and letters first. So this didn't have a square root, this guy doesn't, and then this guy doesn't. And they like to list in order, numbers first, and then the variables in alphabetical order. And then they take a look at the square root part and list that second, okay? So anything that didn't make it out of the square root. And they put that underneath one square root. So 3 didn't make it out, x didn't make it out. So technically, that would be the final answer for that original problem. This would be the simplified version of that problem. Let's try this problem. Now this one, same idea, except there is a 3 out front. That 3 is just going to sit out front until everything out here is simplified, and then we'll multiply it in. So in this, I'm going to go boink, separate this a little bit to make this problem just a little bit easier. Think of it in chunks. I'm going to try to do this as quickly as possible. Here we go. 20, think of ways to multiply to get to 20. I'm thinking, again, you might say 10 and 2, but square root of 10 and square root of 2 are not nice numbers. So I'm thinking maybe the square root of 4 times square root of 5, because the square root of 4 is a nice number. So we'll do 3, square root of 4, square root of 5. That's going to end up giving me nice stuff, so we're good there. Let's go on to the next part. So this would be x to the 4th times x. This guy would be y squared times y. And then lastly, this one we already know right off the bat because it's even. Square root of z squared is just going to be z, okay? Now I'm going to continue simplifying here. So I'm going to go 3 times, well, this is square root of 4 is 2. Square root of x to the 4th is x squared. And if I can't square root something, I just leave it underneath the square root. Square root of y squared is y times the square root of y times z. Now, like before, I'm going to take all of my non-square root numbers at this point, and I can't break down 5, x, and y anymore, so I'll leave them like that. I'm going to multiply those all together. So I'm going to do 3 times 2, 6, times x squared, times z, times the square root. What didn't make it out? Well, 5x and y didn't make it out. So 5x, y are going to be in the square root, and that would be my final answer, simplified, of that. So hopefully this gets you started. The worksheet today is just practicing this. The next time around, we are going to take this one step further and talk about what is known as imaginary numbers. And then next week, we'll wrap everything up by incorporating the imaginary numbers into what you already were doing last week. Okay? You guys have a wonderful day. If you have any additional questions, office hours are every day, Monday through Thursdays, 1 to 2 p.m. If you don't have any other questions, you have a great day. Bye.